Hi everyone, Clement here. Today we will solve the Battle 7 of the Microsoft Excel World Championship. This case was released about a month and a half ago. Today we're on the 15th September, so it was a while back. A case by Klinsmann Langhanz. Very interesting case with a lot of XLOOKUPs involved, a lot of fundamental Excel techniques involved, and very, very good practice case, which I didn't do really well on the day itself, but after practicing and understanding the tricks of that case, I thought it might be useful for all of us to maybe have a look at that video and check some techniques and compare how you guys have done it as well. So it's a time constrained case. We have half an hour to complete it. 7 levels, a story around left-handed and right-handed people, but also how everyone is wired differently for the eye and the foot dominance. Different languages at stake, identified by letters, and 5 bonus questions that do not weigh that much in this case, but absolutely needed to complete to get the full mark. So without further ado, let's dive into this case. So we have a list of people which belong to a field, have a birth year, have a hand dominance reference, foot, eye, and a genetic decay ratio. So for the first level, 1 to 5, we don't really need to worry about the genetic decay. So let's look at, I'll leave the bonus questions for the end, and I'll set the timer on right now. So let's go to level 1, and let's see how much we understand of the case. Usually left dominant people are so-called based on the left hand dominance. In these questions, we're not looking for the hand, but the foot dominance. Find foot dominance in reference. Okay, so that's, I think, a straightforward case. So we want to XLOOKUP this in this table, and we want to return the foot dominance, and that should do the trick. Okay, I'm just going to paste the results here. One technique that maybe we can share right here is to name the columns of the table. So I like to give these ones references. Sorry, did I go through? Yeah, okay. Oh, so we got names here. So that would be names. It's just easier to reference later down the line with XLOOKUPs. This one will be field. This one will be year. Get hand dominance. Just put hand dom, foot dom, eye dom, and this one will be GDK. Cool. Let's move up to level 2. How old are or would be each of the names listed down below in 2024? So 2024 is this year. Oops, XLOOKUP. So we reference their birth year, XLOOKUP, and that's the beauty of naming the columns, because now we can reuse them without navigating to the table tab back and forth. So XLOOKUP in, we're searching for Oprah in names, and we want to return the B year, I think I named it. There you go. Perfect. Let's flip sides. So example 3, Ayrton Senna has the LZO letters for hand, foot, and eye dominance, keeping the same language for each reference but flipping sides. Okay, so we need to flip sides. Let's just try something here. So XLOOKUP of Ayrton Senna in names, and we want to return let's just select the whole field here. To return this because that's a dynamic array. Okay, so we indeed get the letters LZO, keeping the same language for each reference but flipping sides. Okay, I think there's a few ways to approach this one. Being naturally stressed and not doing really well under time pressure, I'll just go for the the most simple option, not necessarily the most elaborate one, but one that I know will work. So definitely not the most elegant, but I think it can do the trick. So I'm just gonna look for each of the letters. So I'm gonna search this letter in this table, and I will return this table. Oops. So I will return this table. It works for P, it works for G, it doesn't work for V, which means if error of this formula, I simply need to switch the columns in which the X lookup is performing the match. L, and again, not the most elegant solution, but probably the most pragmatic one, PGV. So that works. We're gonna copy paste that across, and all we need to do is to concatenate those three letters here, and it does the trick just nicely. All right, level 4. Example 4. According to the hand dominance column, Angelina Jolie is listed with in the table with the letter V, which means left dominance in Finnish. The question then asks, what is the code for the left dominance in Japanese, which is H? So she's Angelina Jolie is listed in the table with the letter V, which means left in Finnish. And we are asking for the Japanese equivalent of this. So basically, we need to stay in that column. So I think this one is a bit of a trick question because it's well, let's verify this. X lookup of Japanese in this table, and we want to return the we're talking about the hand dominance. So this one, and that's H. P. Yeah. So it's basically what is the left dominance of that language. The person in front of it actually doesn't matter in that case. It's a bit of a trick. Level 4. If we sort the table alphabetically by name, then chronologically by estimated birth year, amongst the ones sharing the same field, what's the adjacent name on the list? So we have a whole list of names, fields, and estimated birth year. We want to sort that list in a special way, and we want to find whoever is younger or older than the person that's provided here. So let's maybe create a different page for this one and say this one will be level 5. So here's how I figured this out after a few tries. So we want to sort that array in what's given to us. So we want to sort table 1. We will sort by table 1, and we need to first group people by the field. So field doesn't really matter, I guess, if the field is ascending or descending, but I'll just put it there. Then birth year, ascending, and finally, if there's a tie, by names, ascending. So wonderful dynamic arrays in Excel gives us this table. So now what we have to understand, in the case of Charlie Chaplin, it gives us Pablo Picasso, which is older, was born before. So what we're saying is if it's older, you need to reference this, minus 1 row. If it's younger, it's this plus 1 row. So we need an equivalent table here. Just going to be lazy and take the two values around here. Say younger means I go down 1 row, older I go up 1 row, so minus 1. And what we'll do is an index of this column where we want to match this person in this column. So match returns a number, in that case the row number, and we want to add XLOOKUP of this in this column, and we return this value. Oops. Oh, okay. Plus XLOOKUP of this. Pablo Picasso seems to work, and then we can just bring it down. Let's confirm. All good to go. So yeah, the trick in this one is to sort it by field, birth years, and in case of tie with the birth year, names kicks in. Level 6, we're dealing with genetic decay. So it's super important to follow the example, because that really helped me to understand the conceptual effects of genetic decay. So I'm just going to follow exactly line by line what it says. I'm going to do the same thing and hopefully get the same number at the end. So Flanders was born in 1932, but the first occurrence of the ratio is in 53 because it happens 21 years after the 21st birthday. So we know we're going to need that information. Let's immediately XLOOKUP Flanders in names, and we want to return the birth year, B year, I think. So that's the birth year, and that's going to be when decay starts. The genetic decay ratio is the number we want, equals XLOOKUP again of Flanders in names, and we want to return this time the GDK. It goes up by 10%. After that, the ratio increased 10% of the last value per year. And then there is a sub component to it, is the number that you need to reach depends on whether you start with the right eye dominance or with a left eye dominance. As is left eye, the first year exists, the 3 limit was 1966. If he had been right-eyed, it would have been a 7 ratio to hit, which is written here. So we need to understand whether he's left or right-eyed. So again, XLOOKUP of Ned. In names, we want to return the item. We want to understand whether that letter belongs to left or right, so we're gonna XLOOKUP that value. Having trouble with my double L's today. We want to XLOOKUP that value in that table, and we will say send that table. Not the most elegant option, but it returns something, which means yes, he's a left-handed. Had it been an error, it would have been right. So I'm just going to say, so we know that's left. Say if error of this item, I'm just going to put right eye or right. And anything that's not right is left. Okay, so now we need to understand when they're going to reach the ratio of his So is left-eyed, so he needs to reach 3. So there is a very useful mathematical formula here that I figure we need to know. Found out a while back, so it's n per, and n per gives you the amount of time that you need starting from point A to get to point B with a given interest rate. So the rate is 10%, 0.10. We don't need PMT, we need to minus the starting point, which is the genetic decay. And we need to indicate the value to reach, which I haven't done here yet. So we need to say equal if this equals right, then 7. Anything else would be 3 to reach. Very good. And now we can plug in the n per with a rate of 0.10 minus genetic decay, and we need to reach that value. It will take 12 years to switch eye dominance. years plus when it starts equals 1965.49. We're just going to round it up, and we get 1996. We just have to apply this to the rest, hope for the best, and it works. So that's how this piece was extremely useful for that case. Year, when it happens, decay, left or right, ratio, how much time, sum it up, round it up. So that was a multiple steps question. Probably the most difficult in the whole case. I think I would argue level 6 is actually more difficult than the one coming up. Level 7, we will find the age at which each of these people change eye dominance, rank them according to what age they change eye dominance, and deliver the result for each sequence in that format. So maybe not the most elegant solution as well, but one that I found just works just fine for me. So level 7, let's make some space. Let's take the whole list, including the example. Copy paste that. We know we need to split that using the column to text delimited by a bar, vertical bar. What it usually gives is a blank space somewhere, so we just want to make sure everything is clean. Just going to trim each of these values. For some reason didn't take the last one. I'll do that manually. Whoops. Okay, let's go manually. So Barack Obama, Mozart, and they all end up in the same cell. Now I need to split this, which will be Oprah. No, here they are. Okay, not sure what happened here. That's all right. So trim, back to trim. Trim removes any space before and after the starting of the cell. So now we're working with clean data. What we need to do in that case is to understand at what age they will change. So we need the age, not the year that we had just before. But the logic is kind of the same. And out of, I guess, time pressure, I'll just bring over the same formula, customize it a little bit to make sure it fits this list of people, and see how that goes. So let's bring the formula over here. We need a unique list of all these people. So let's do a 2-row unique of the entire list. Oh, 2 columns, sorry. So we have a unique list of all the people given in that sequence. And we will want to understand for each of them what is the year at which they change, so we can recenter formulas that we imported. This one will just need to reference the previous page because it's looking for something that doesn't exist on that page. HLOOKUP this. In that sequence, we want to return that sequence. Okay, what age would they be? So that's when the decay happens. We don't want to round those years too early as well, so let's just work with everything we got. We will round up the final numbers in the end, and that will be this minus the birth year, and we will round up this number. Okay, so let's just apply it to the whole list. Great. So we're halfway through. Now we need to understand for each sequence at what age each of them changes. So I think it's Benjamin Franklin. We're going to XLOOKUP this in the list. Return. Oops. Sorry, let me fix that. So we will XLOOKUP Franklin in here. Return the age. What's going on? Oh yeah, that's right. So HLOOKUP of Franklin. That's better. That is better. Okay. And now we can follow. We can continue. Okay, so we have the age at which each of them changes I dominance. We'll need to concatenate to filter that table based on that sequence. So we will sort by this array, and we want to sort it by this value in ascending order. Cool, we're getting closer and closer. We want the first letter of each name. We're going to use dynamic arrays here as well. We want the left of this one. Maybe a concat would work. Concat. Yes, it does. Wonderful. And we need the and the average of these values. And let's round them up. Round up the average of these values, 0. Looks about right. So if we put that back in the case, we end up with 4 marks. Cool. So now let's look at the bonus questions. What's the name of the person with the lowest genetic decay ratio from the field fiction. There are many sorts options to do it. I'll just go very bluntly to the field section. Sorry, the field fiction. Lowest genetic decay ratio, link Zelda, and I'll just copy paste over. Considering all three dominances in the table sheet, how many left dominant occurrences are there? So let's just count if in table 1. Criteria range 1. So the total left letters we get is 96. How many times did the least frequent language appear in the table, considering hand, foot, and eye dominants together? And this time around, we also need to consider the right. So any language. So I'm just going to copy paste that over. So this is left, this is right, and we have this plus this. Okay, so the smallest number here would be 20, and that would be Finnish. And it happens 20 times. How many times? The answer is a number. 20. What is the only alphabet letter that doesn't appear amongst all level 5 answers? So level 5 answers. Okay. So we need to get these ones. Just gonna make a bit of space here. So when it comes to counting letters, again, probably more Lego options, but I found this one works just fine. First of all, you want to work with clean letters, so you want to upper everything. You want to create a matrix and count each letter for that name. So I like to use the sequence function and with character sequence 25 1 65 1. This is like something to almost know by heart. Sorry, 26 with the Z, awesome. And we want to see what is the length of this versus what is the length of the same thing after substituting in that text an A that we replace by nothing. And all we got to do is to drag this formula across and eventually sum it all up and find the one that doesn't appear. So which one is 0? It is Q. Based on level 6 rules and considering every name in the table sheet, what is the latest year on any given person? Any of the given persons will change eye dominance. So we kind of did that with level 7. So here we had everyone in the set of names that was given to us. We don't know if it's the whole list, but we have the formula ready. So what I'm going to do is just to copy paste everybody, which is 47 47 names. Let me see. And find what is the maximum of the year. Oops. Some old defects here. So what is the maximum? Let's run this up. 2056, and this should this should work. So this gives us the full marks in just, I guess, like 20, 27, 28 minutes. Again, not the most elegant solution, one that does the trick and that leverage simple yet affordable sorts and XLOOKUP functions. There, I think if I had to do it again, I'll probably manipulate the letters table a bit more. So the one that gives the translation between left, right-handed, I'll probably make that just one single column and map it against left or right. But yeah, that's about that. I found this technique very ugly, but frankly, it just works. So when it comes to time constraint problems, I think it's not worth to dive into details too much. And yeah, I think we need to pay attention to these trick questions. Easier said than done on the day, obviously, but it's sometimes things are simpler than they look like. So I wish you guys all good luck for the next battle happening in a week time. And please comment on the video, reach out if you have any questions, suggestions to do things better, faster, if you did it in a different way. Always looking forward to elegant solutions rather than quick and dirty ones. And yeah, hope we'll all see each other at the Excel World Championship sometime in December. Bye for now.